that means we're live. Alrighty, okay, great. So we are going to look at some of the reasons why we factor quadratics. And one of the reasons that we factor quadratics is so that we can solve quadratics. So we're going to start off with a quick fact, and we are going to exploit this fact throughout the rest of the class. And, well, to be honest, we're going to exploit this fact for the rest of the year. So let's check this out. So we're going to solve quadratics by factoring. Okay, so let's start off with a quick fact. Oh, that's too thick. Okay, quick fact. Okay, if A times B equals 0, that is, if the product of two numbers is equal to 0, what can you say about those two numbers? Yeah. One of them has to be 0. Doesn't matter which one. One of them must be 0. There's no other way that's possible, right? Like you couldn't have like one of them like really small and the other one's still really small. You could get very close to 0, but it wouldn't be equal to 0. So one of those must be equal to 0. So we'll write if A times B is equal to 0, then A equals 0 or B equals 0. And I'll just say as a little side note, there are no other possible outcomes. One must be 0. One of them. We don't know which one. So we say we don't know which one. We also don't know. We don't know if they're both. Now close those brackets and say equal to 0. To 0. Okay, so maybe both of them are, but at least one of them are, right? So the possibilities is that A equals 0, B equals 0, or A is equal to B is equal to 0. Those are the only possibilities, okay? So we are going to exploit that fact when we try to solve quadratics. So let's say we're given a question that looks something like this. So let's see if we can solve this equation right here. Let's say we've got x minus 1 times x plus 1 is equal to 0. Okay? Let's say that that's an equation that we have. Okay? What do you think? Mm-hmm. Yeah, you're bang on. I'm gonna sort of rewind a little bit just so we can start from the beginning, but you got right to the punchline. So because we have a product, so this is a product that's equal to 0. We've got a product that's equal to 0. That must mean that one of the factors must be equal to 0. That's supposed to say 0. Z-E-R-O. Okay. That means one of the factors must be equal to 0. Okay. We don't know which one. We don't know if it's both of them, but at least one of them is equal to 0. So that means, well, the factors are, let's write the factors. The factors are x minus 1, x minus 1, and x plus 1. Okay. So those are the two factors. So I know that this one must be equal to 0. So I'll say that x minus 1 must be equal to 0. Or x plus 1 is equal to 0. Okay, and you can kind of see where this is going now. Now we can actually solve these. Linear equations are very easy to solve, right? We've been solving these since grade 7. Okay, so really all that's involved here is take the 1, put it on the other side, and we get x is equal to positive 1. And then the other one is x is equal to negative 1. And that's what our solution is. So our solution, the way we would actually write our solution is in the following way. So our solution is x is equal to 1 or x is equal to negative 1. Okay? We don't have to include the other option of saying maybe they're both equal, because that in that case that's not actually possible, right? X can't be two things at the same time, because if x was equal to 1 and it was equal to negative 1, then that would mean that 1 is equal to negative 1, right? So we just write or, right? We've got the two options. So x is equal to 1 or x is equal to negative 1. Another way of writing it is we can say I'll write alternatively, we could say that x is an element of the set 1 comma negative, oops, that's not 1 comma negative 1. And then we would close the set. That is a Greek E or an epsilon. So this is a Greek, I should have a capital letter actually. So that is a Greek letter epsilon. Some people call it epsilon. I call it epsilon. Most people call it epsilon. So that's and if I draw it really big, it kind of looks like a euro, except just like with one little line in the middle of it. So that's a Greek letter epsilon. It's the Greek letter E, yeah, and it stands for element. Yeah. Oh no, sorry, that's not supposed to be. It's supposed to be like on the same line. Yeah. So it should be like if we were in grade school and you had like those lines, like the line paper with the dots in the middle, it'd be like this. Yeah. So yeah, no, it's always good to know this notation. I like talking about notation because it is important. And that means element of. And the element of means that you are a member of a set. So I'll write AKA member of a set. Okay? And a set is a collection of things. Doesn't really matter what is in your set as long as it is a thing. In this case, our set, so these curly brackets here, these indicate a set. Okay? So that's another way of writing this. You might see this come up every so often. I prefer just writing it in the first way. That's how I'm going to write it probably 95% of the time. Every once in a while, I might throw this in. I think it's important that you see this notation because this notation is going to come up more and more often, especially as I get closer and closer to grade 12. By the time you're if you ever end up deciding to study calculus, this is the notation that you tend to prefer, because this is a lot more robust. You can describe all sorts of really interesting sets using this type of notation. And we might explore this notation a little bit more in this class, especially when we start talking about something called domain and range. But anyways, this is a set, and there's all sorts of ways of sort of changing this type of notation to describe different things. But if you just put a bunch of things separated by commas, it's just a set that involves a bunch of things. So you're saying that X must be one of those things. And in this case, we've got two things. So that's kind of the basics of what we're doing today. So that's a whole, well, not the whole reason, but that's one of the main, what am I trying to say? The main, not, I guess we could say reason Yeah, let's just simplify it. Let's say that's one of the main reasons why we want to factor quadratics. The word I was looking for was motivation. One of our primary motivation for factoring quadratics is to solve quadratic equations. So just so we're clear, a quadratic equation is an equation, i.e. has an equal sign. Okay, that's what makes an equation, right? If it doesn't have an equal sign, what do we call that? Close, yeah. A term could be something without an equal sign. Also starts with an E. Expression, yeah. So a quadratic equation is an equation that has a quadratic expression. Okay. So to solve a quadratic equation, one method to do so is to solve it, or is to factor it. And solve for each linear factor. Okay? So that's our goal. That's what we're doing. That's our motivation here. Okay, so I'm going to start us off with a couple of questions here just to warm up. Are there any questions so far before we do some examples? Okay. Yeah. Okay. You're thinking ahead. That's good. I like that. But let's just keep our eyes on the prize for now. So let me, how do I do this? I want to zoom in so I can see it from here. Zoom, 250%. Great. Now I can read this question. Okay, so let's solve this equation. K squared minus 3k minus 28 equals 0. All right. K squared minus 3k minus 28 equals 0. So let's factor it. Let's factor this. So starting off, to factor it, I'm going to write these two brackets like so. And I'm going to keep the equals 0, right? We still need to write out that the fact that this is still an equation equaling 0. So I am looking for two numbers whose product is 28, whose product is negative 28. I really need to make sure that I include that negative. So if the product is negative 28, that means one of the factors must be positive and the other factor must be negative, right? Okay, and then their sum must be negative 3k, or I guess in this case, just negative 3. Okay, and so if one of them is, if the sum must be negative 3, then the negative 1 must be the big one, right? So among the two factors of negative 28, the big number must be negative, the small number must be positive, because when I add them together, I get negative 3, right? So my mind is going towards 7 and 4. So that'd be positive 4, and negative 7. That's kind of what I'm thinking, right? Because positive 4 and negative 7, you multiply them together, you get negative 28. You add them together, you get negative 3, right? So then I've got an x over here and an x over there. All right. So yes, do you have a question? Oh, yes, yes, good call. Thank you. Yeah, that should be K. Yeah, good call. Definitely supposed to be K. And then now we know that, well, we've got sort of two things to solve now. I know that one of these things must be equal to 0. Okay, so if we have that K minus 7 is equal to 0, that must mean that K is equal to 7. The other option is that K plus 4 is equal to 0. Therefore, K is equal to negative 4. So those are our two possibilities. So our solution K is equal to 7 or K is equal to negative 4. And you could also write, if you wanted to, or K is an element of the set 7 and negative 4. Okay, so not too bad, right? But now you can probably see some of the importance of factoring these quadratics, right? Now that we've factored it, we can see that it gives us a clear solution of which one is which, right? Or two different options. I want to try a different one here, slightly different. Let's try this one. So we're at about 16 minutes, so I'm gonna try to end it pretty soon so that we can have nice short videos. One of my goals. Okay, so another example. We've got, let's solve this equation here. How about x squared minus x minus 10 equals, negative 4. We have a problem. If we were to factor this, right, and then it was equal to negative 4, let's say that we managed to factor it, who cares what's in there? But now the issue is that, okay, well, now we know that this thing times this thing is equal to negative 4. Well, even if we just restricted ourselves to whole numbers, there's a lot of different possibilities, right? We could have one of these is equal to 1, while the other one is equal to negative 4. This one could maybe be equal to negative 1. This one could be positive 4. We could have 2 and negative 2, or negative 2 and 2. But then what about even like what if we started including fractions, right? Yeah. Yeah, exactly. So there's an infinite number of solutions. But with a little bit of cleverness, we can get around this. Any thoughts? Yeah. Yeah. Yeah, just that's why we learn how to do algebra. We want to be able to just manipulate the equation, be able to move it around, massage it until it looks the way we want it to look. So let's set it equal to 0. And we can do that by adding 4 to both sides. So we're going to add 4 to both sides. So that will cancel that. So we're left with 0. And then we've got, well, negative 10 plus 4. That's negative 6, x squared minus x. And now when we factor it, we'll have a product that's equal to 0. And we can use our little trick to determine that each of those factors must be equal to 0. Any thoughts on this one? What are the numbers we're looking for? You can just shout them out. Sure, great. Negative 3 and 2. Super. Negative 3 and 2. So I've got x minus 3 and x plus 2. That gives me two possibilities. Bada boom, bada bang. X minus 3 equals 0, and x plus 2 equals 0. I'll kind of just solve them simultaneously. X is equal to 3, or x is equal to negative 2. And therefore, we get x is equal to 3, or x is equal to negative 2. Not so bad, right? Not so bad. Okay, I'm going to do one more example. Last example of the day. Well, of the video, rather. I'll probably do a couple more examples after the video. Let's try one just slightly more challenging. Okay, let's do, yeah, that one looks good. So let's try this one here. So e.g., hey, we're going to solve this bad boy. 3v squared minus 14v plus 9 equals negative 6. Negative 6. Okay, super. Oh, okay. Alrighty, so that looks good. Okay, cool. Okay, so this one is going to be slightly different than some of the others. So this one will require some of the skills that we covered in yesterday's class. So if you're not super comfortable with what we did yesterday, we can cover some of that again today. But you know, for the sake of the video, I'm just going to assume that we're good. So our first step is we got to set it equal to 0. Otherwise, that trick doesn't work. The trick with the factors. So let's add 6 to both sides. We'll get 3v squared minus 14v equals, oh, sorry, not equals, plus 15. That's equal to 0. Awesome. Okay, now we got to factor this thing. Yeesh. It's a little bit trickier when you've got this big 3 in the front. But the trick that we learned yesterday was the following. We make a little cross. And when you're first doing the cross, let me make a nicer cross. When you first start learning the cross, or some people call it the diamond, you might want to put symbols, multiplication right here and addition there. Or if you like the X for multiplication, you can do that too. Okay, and we'll start off by multiplying the first and last number together. So that's going to be what, 45. And then we put what I think is the middle number, negative 14 there. Okay, so we're looking for two numbers. We're going to put them there so that when we multiply these two numbers together, right? When we multiply them, we get 45, and when we add them together, we get negative 14. So we should have two. I'm thinking two negatives. Yeah, you got an idea? Negative 9, negative 5. Yeah, that would probably be the trick. So negative 9 and negative 5. So that would do the trick. So what we're going to do then is we are going to split this 14v up. And I like to color code these things when we're first doing this. So let me just choose a different color here. Let's do yellow. And I'm going to make this this and this yellow as well. So these two things will be the color yellow. Okay, so we're splitting up the negative 14v into negative 9 and negative 5. So that's going to look something like this. Oops, I wanted yellow. So I'll write negative 9v minus 5v. So I'm hoping that it's clear that these two things are equal, right? Negative 14v is the same thing as negative 9v minus 5v. Same thing, haven't changed it. Let me include everything else. I've got 3v squared, and then plus 15 equals 0. Okay, now what I'm going to do is I'm going to kind of split these two things up. And what I'm going to do is I'm going to write plus negative, and then I'll put a bracket there. Okay, so now what we're going to do is we're going to factor both of these as much as we can. We're going to look for common factors. And the way we set it up is the numbers that we chose, they must have common factors in them. And in fact, when we do so, we've done so in such a way, and if you're not entirely sure why, you can refer to the video from yesterday. That's kind of what we did yesterday, is we explored the reason why this is going to work. It works every time. But at some point, you kind of have to stop thinking so much about the reason why things work and just do them. Otherwise, your brain is going to explode. There's just too much going on. So all we have to know now is that we're just going to factor out the largest factor that we can. So any thoughts of what we can factor out of this one? So we're gonna sort of try to yeah, we don't have to worry too much about the fact that this is negative. We can still factor out a 3 from a negative, okay? So we can factor out a 3. Anything else? Yeah, we're gonna have it as a positive 3. And anything else? Pardon me? A v, yeah, exactly. Yeah, 3v. So we can factor out a 3v from that first one. And then what's left is, well, we just have a v left over in the first term and a minus 3 in the next term. Okay? Okay, now what we're going to do next is we are going to see what we can factor out of this one. Now, just as a little tip, we are going to want the second set of brackets when it's left over, we're going to want it to look just like this. Okay? So we're going to want to factor out this negative 5 here. So the number we're going to factor out is that's going to be a negative number. So I'm going to just go ahead and write minus 5, because I know that 5 goes both into negative 5 and 15. And when I do that, what's left over in the brackets is, well, I leave the v there because I wasn't able to factor out the v this time. Plus, well, it's actually not a plus now because I took out a negative 5. And 15 divided by negative 5 is negative 3. And that's all equal to 0 now. And let me just change that back to pink. Equals 0. So the way we set it up is that we're going to have the same factor in both of these terms here. So what we can do now, and let me be clear about this. This takes lots of practice. So if you're feeling a little overwhelmed, like, whoa, what is going on? Just practice a few of these. The more you do them, the easier they get, okay? So I'm going to factor out a v minus 3. Okay, I've factored out a v minus 3. And what's left over is, well, if I factor out a v minus 3 from this term here, all that's left over is the 3v. So I've got 3v, and I'll leave that in pink here, 3v. And then when I factor out a v minus 3 from the next term, what's left is a minus 5. So minus 5. And that's equal to 0 now. And now we're pretty much done. This is where like the majority of the work is in the factoring. Factoring is the hard part. And I'll tell you what, factoring is one of those topics that students in university still struggle with factoring. It's one of those things that's it's a challenge. It's not an easy process. So if you're feeling like this is maybe a little overwhelming and challenging, it's okay. This takes time. It really does take time. So let's go ahead and solve this. So now that it's factored and the product is equal to 0, we get two possibilities. One is that v minus 3 equals 0, and the other is that 3v minus 5 equals 0. The first possibility is pretty straightforward, right? It's just v equals 3. And the other possibility is, well, this is still a linear equation, still straightforward to solve, but it'll take 2 steps to solve, right? So the first is to move the constant to the other side, so that gives us 3v equals positive 5. And then we're going to divide both sides by 3, and we get v is equal to 5/3. Okay? So our final solution, our final solution is that v equals 3 or v equals 5/3. Now, there's one thing that I haven't really talked about in this lesson so far, which in a lot of ways is possibly the most important thing, which is talking about how we can verify our answers. So that's a really nice thing about mathematics, is that it should be easy to verify your answer. That way, if you're writing some kind of test, or if you really want to be sure that your answer is correct, you don't need an answer key, right? A lot of questions, not all the questions, but a lot of questions on a math test, you can actually verify your answer and determine whether or not you got the question right. Not a lot of subjects do you have that that possibility, right? So let's see if we got this correct. Okay, so let's verify. So to verify our solution, we will take the original equation, the one that we haven't touched, right? It doesn't make sense to take this equation because the whole point is that maybe we made a mistake somewhere in all of that, right? So we are going to take the original untouched equation. I'm just going to copy and paste it, but if you're doing this with a pencil, you'll have to write it down again. So we'll just paste that there. And we are going to check that both the solutions that we got when v is equal to 3 and when v is equal to 5/3, that gives us a a solution that is correct. So in other words, that the equation holds true. So let's try that. I'm just looking for the right color here. So let's go ahead with this. So let's try what happens when v equals 3. Okay, so this is going to be 3 times, well, 3 squared. I'm just replacing all the v's with 3's, minus 14 times 3 plus 9 is equal to negative 6. So now what I'm going to do is I'm just going to simplify this and hope I get negative 6. Right? And at this point, it's really just a hope, right? We don't actually know. We're trying to make sure. If it's not equal to 6, then we've done something wrong. So 3 times 3 squared, that's 3 times 9, which is 27. We got 27 minus 14 times 3. Well, 14 is, this is how I like to do these things. I like to break it up. This number is too big. So let's just remember that 14 is 7 times 2, and then I'm multiplying that by 3. 2 times 3 is 6. 6 times 7 is 42. So this is 42 plus 9 is equal to negative 6. And I guess what we should really be doing, I kind of like to emphasize that we don't know this. I like to put like a little question mark there. If you're in computer science, you might I think the term is a double equal sign. Hello. This is high school. Yes, absolutely. We're just live on YouTube, but that's okay. No, now's a good time. I guess I'll just say if you're on YouTube, I'll post the final answer. We're gonna be done in 2 minutes anyway. So, okay, bye bye. Good. All right.